McCartney Company manufactures guitars. The company uses a standard job order cost accounting system in two production departments. In the construction department, the wooden guitars are built by highly skilled craftspeople and coated with several layers of lacquer. Then the units are transferred to the finishing department, where the bridges of the guitars attached and the strings are installed. The guitars also are tuned and inspected by the finishing department. The diagram below depicts the production process, and you see how it moves. We start off with the construction department, where the basic guitar built from veneered wood takes place, and then in the finishing department, the bridge and strings are attached, the guitar is tuned and inspected. Alright, now each finished guitar contains several pounds of veneered wood. In addition, 1 pound of wood is typically wasted in the production process. The veneered wood used in the guitars has a standard price of $12 per pound. The other parts needed to complete each guitar, such as the bridge and strings, cost $15 per guitar. The labor standards for McCartney's two production departments appear as follows. The construction department has 6 hours of direct labor at $20 per hour, and the finishing department requires 3 hours of direct labor at $15 per hour. We've got some other facts we need to look at as well, so let me reposition the screen so we can read those. Okay, now we pick up right here. The following pertains to the month of July, and I'll just read down. I'll position the mouse on the left so that you can read it clearly. There were no beginning or ending work in process in either department. There was no beginning finished goods. Actual production was 750 guitars, and 450 were sold on account for $390 each. The company purchased 9,000 pounds of veneered wood at a price of $12.50 per pound. The actual usage of veneered wood was 6,750 pounds. Enough parts, bridges and strings to finish 900 guitars were purchased at a cost of $13,500. The construction department used 4,275 direct labor hours. The total direct labor cost in the construction department was $81,225. The finished department used 2,355 direct labor hours. The total direct labor cost in that department was $37,680, and there were no direct material variances in the finished department. Now, these are facts you might have to go back to and as you see the answer and see how it was computed. Let's tackle the first requirement. Prepare a schedule that computes the standard cost of direct material and direct labor in each production department and in total for the month of July. Alright, give me a minute and I'll put that on the screen for us. Okay, now you see the standard cost schedule for the construction department, it's the first column, and the finishing department. And what we know is the direct material and parts in finished product will start off with the standard quantity. 7 pounds of veneered wood. Allowance for normal waste gives us a total of 8 pounds. The bridge and strings take 1 set. They told us that the standard price was $12 per pound for veneered wood. Bridge and strings, $15 per set. If we take the 8 pounds times the $12 per pound of the standard price for the construction department, we come up with $96 per guitar as the cost of direct materials. Actual output in July was 750 guitars, so the total standard cost of direct materials in July would have been $72,000. Now we can go through the same calculation for the finished good too. 1 set at $15 per set is $15 per guitar. 750 guitars were actually produced, and that gives us a total standard cost of direct materials in July of $11,250. Now let's take a look at direct labor. Standard quantity, 6 hours given in the problem, times $20 is the standard rate, so a standard labor cost per guitar is $120. In the finishing department, it's 3 hours times $15 per hour, or $45. When we multiply both of those standard cost per guitar for each department times the actual output that occurred in July, we come up with $90,000 as the standard cost of direct labor in July for construction department labor cost, and $33,750 for finished department labor cost. Okay, now let's look back at the problem requirement 2, which says prepare 3 exhibits which compute the July direct materials and direct labor variances in the construction department and the July direct labor variances in the finishing department. So we'll take a look at direct materials first. Okay, and now you can see the direct materials price and quantity variance. Well, how did we compute this? We know that actual material costs were $112,500. We know that actual quantity was 9,000 times the actual price of $12.50 gives us $112,500. And by the way, if we don't have all of the numbers here to produce the solution, what you need to do is jot in the numbers that you do have and work your way backwards, and eventually you can force a number out. For instance, if we had 112,500 in a problem like this and actual pounds of 9,000, you could compute the actual cost. If you knew the actual price and the actual quantity, you could multiply it together to determine the actual material cost. But once you play this game of fill in the missing blank, you can put together this entire schedule. So let's jump over to the standard material cost. 6,000 pounds allowed, which would make sense for the output we had, times $12 standard price, which was given, says 72,000 would have been the standard material cost we expected to incur if we achieved the standard. So if we compare the 112 to the 72, we know there's some variances involved. Alright, well, let's compare the difference between the 9,000 actual quantity times the $12.50 actual price versus the $12 standard. When we compare the 9,000 times the 50 cents difference, we wind up with a 4,500 unfavorable direct material price variance. Now, the other way you can calculate this is come up with the actual material cost and then compute the actual quantity at standard price, which gets us 108,000, and the difference is 45 unfavorable. Then we need to take a look at the pounds used, and this would have been the actual pounds used in production, and compare that to the standard material allowed, which would have been 6,000. So we've got 750 pounds difference times $12, and that winds up with a comparison of 81,000 versus 72,000, and that derives a 9,000 unfavorable direct material quantity variance. Okay, next we look at the direct labor rate and efficiency variances, which you see on the screen right there. The actual labor cost was $81,225, and we multiply 4,275 hours used times $19 per hour to derive 81,225. And again, if you get problems like this, you may be given this number and need to compute the hourly rate, or you may be given the total actual labor cost, the hours used, or the actual rate, and you need to determine the actual hours used. It's a case of filling in what you don't know to be able to complete this schedule. Over on the standard labor cost, we knew that there was 4,500 hours allowed per the production we had during the month, times a $20 standard rate, giving us 90,000 is the standard labor cost. When we compare the 90,000 standard labor cost all the way over to the actual labor cost, we derive the total labor variance. It's 8,775 favorable. It's favorable because the 81,225 actual cost was less than the 90,000 standard labor cost. Now, once we have the direct labor variance, we can break it into the two pieces, right? If we take the actual hours times the actual rate versus the actual hours times the standard rate, we compare $81,225 to $85,500. The difference between those is a 4,275 favorable direct labor rate variance. It's favorable because the actual labor cost was less than the actual hours at the standard rate. Then we take that same actual hours at the standard rate, compare that to the standard labor cost, and we compute a 4,500 favorable direct labor efficiency variance. We can add the direct labor rate variance to the efficiency variance to derive the direct labor variance. Alright, now in the previous example we were looking at the construction department. Now we go through the same analysis for the finishing department. We compare actual labor cost to standard labor cost. If we multiply actual hours times the actual rate versus actual hours times the standard rate, we're able to derive an unfavorable, in this case, direct labor variance to the tune of $2,355. Then if we compare the actual hours times the standard rate versus the standard hours times the standard rate, we're essentially multiplying the standard rate times the difference between the standard and the actual hours, and we were unfavorable in the finishing department here as well. Adding the two unfavorable variances together gives us a total direct labor variance for the finishing department. Next, we take a look at the third requirement on the bottom of the screen here. It says prepare a cost variance report for July similar to one shown in Exhibit 10-4. And now you can see the cost variance report on the screen. So we have two departments, and we start off and we show what the standard cost was given as the actual output. $72,000 for the construction, $11,250 for the finishing department. We identify the direct material price variances, which was $4,500 unfavorable for construction, $9,000 unfavorable for construction as well, but this is a direct material quantity variance. The direct labor at standard for labor was $90,000 for construction, $33,700 for the finishing department, and we had two favorable variances in the construction department amounting to 4.75% and 5%, and unfavorable in the amount of $2,355 for the direct labor variance and $1,575 unfavorable for direct labor efficiency variance. So the whole purpose of the cost variance report is it allows you to see what happened versus standard in one summary table.